Hello, everybody. My name is Nathan Hill from the Fraternal Order of Locksport, and I'm here to talk to you about lockpicking today. So first, a little bit about myself and the group. Tools is a Fraternal Order of Locksport. We're based out of Bloomington, Indiana. We do get together once a month, drink beers, pick locks, local pub. We're not criminals or anything like that. We do some lockpicking villages, events at different conferences. Of course, we're out in the back there. We do lockpicking competitions for folks that put them on. A little bit about myself. I'm a Phoenix admin for the University of Indiana. Pretty obvious what I do. So I guess to get started, the first thing people ask is the law. What is it for people to have picks? And what we do tell people what the law is as long as you're not committing a crime in most places, you're okay. If you're doing something dumb or illegal and it picks on your shirt, you get charged with having burglary rules. So again, picking locks that you don't want or have permission to pick, there's nothing wrong with that in most places. There are some states where just having picks is a crime, so check the local listings. But Indiana and Kentucky are fine with that, as long as you're not doing something wrong with it. And of course, there's exemptions for locksmiths and whatnot. So TSA, got a couple of interesting anecdotes about that. At one point, I was coming back from DEF CON with a friend, and I noticed he gets pulled over in a security checkpoint area, and they go to his bag to pull out his DEF CON badge, circuit board, and pull out more circuit components, lock picks, all these things. They find this air gel. Sorry, sir, this is more than 3 ounces of circuit. I just carried on 55 pick sets on my carry-on out to Portland this week. So really, it's not on their checklist. They don't carry it. It's a tool. It's less than 7 inches long. It's not really dangerous. So to get started briefly, locks. In order to start picking, it's good to know how a lock works. And the green part is the body of the lock. The yellow circle or component at the bottom is the plug. There's an empty space where the key goes, that's a keyway. The red, blue component with the spring on top is the pin stack. The pin stacks will line up and lock the plug. After turning the key in, it lines up what's called the shear line of all the pin stacks so the plug can turn. In America, or in North America, we have a pin stack above the key. In Europe and other places, the pin stack is sometimes underneath. The only difference, one thing I've heard is that that's to keep debris from getting into the wall, the chambers with pins. But the driver pin is going to be a pin on top. The key pin is going to be the pin that contacts the key at the bottom. So when I reference pins, I'll try to reference it by driver pin and key pin. So your first pick set, if you have a pick set, is you're going to have a tensioner or two. The snake and half diamond are going to be rakes. There's lots of other types of picks too, but these are most common. Rakes are basically for raking in and out of the lock. It's not very sophisticated. A hook that we've got there is for probing the pin stack, or pin by single pin picking, or pin by pin. And it requires a little bit more touch, but it's much more effective against locks that have security pins and whatnot. We'll get into what that is later. There's also the ball pick, which is not used very often, but it can be handy in a couple of locks I'll show you later on. So ways to open a pin-tumbler lock, of course, it's using the key, brute force, which is what those locks are designed to prevent against. Manipulation, which covers a number of different topics, of course, picking, bumping. Can I see some hands for people that have picked a lock before? Good, good, all right. Anyone here who has heard of bumping? Okay, so looks like folks are at least have a reasonable idea. Well, I'll cover these, all these things in more detail, of course. But there's also bypass attacks, which bypass the lock mechanism and will open the lock. Decoding attacks, which may not open the lock, but allow you to kind of key for it later on. So first off, when you're picking, you want to know how many pins are in the lock. So if you take like a half diamond, put it in upside down, raise all the pin stacks up, and then pull it out, you can kind of hear and feel how many pins, if you put it up to your ear, how many pins are in there. And so that's your first problem, is to know how many pins are inside. The reason lockpicking works is because there's, in a perfect world, you can make a lock perfect, but it's not possible. There's mechanical defects, even with high tolerance machining equipment and stuff. You're still going to have a variance from pin to pin made on the same machining gear. So the holes might not line up and plug correctly, pins might be different thicknesses, and that's what we're taking advantage of. To start with picking, I usually recommend start raking your tensioner, which is the hockey puck shaped tool which you put in the Keyway. That's where most of the technique is. You put too much pressure, and that's what most beginners have a problem with, and you're going to wind up all the pins and not just the biggest pins in the stack. So I can get this to play. Sorry about this. This is not my laptop. Not sure if I'll get the video to play here. Okay, well, we may not have video, so...
What happens if you bring it F5 to bring it up to full screen? Or Shift F5, I'm sorry. Forward. I try to see an intro or click on the screen. How do you normally bring it up to life? How do you do that now? You can't click on it from now.
All right, well, I had some nice videos, which I normally use in my slideshows. It kind of demonstrates the these issues very well. Sorry about this, folks. All right, let's move on. A few things with picking is that you can, if you do pick a lock, you're operating in ways that are not, it wasn't intended to be operated, so you can damage it. Don't go home and pick the front door and lock, or on your front lock on your door. You can get it stuck in like 180 degrees out, or sometimes springs can get pulled out and stack and stuff, and that's not very good. So if you're going to go, if you, the first time you're picking a lock for today, don't go home and don't go home and pick a lock at home. Just buy a lock at the store or something, get some padlocks or something, practice on. So this will demonstrate single pin picking here. And basically with single pin picking, again, using the hook, you've got some tension on the lock. You're going to use your hook to probe each pin stack and raise each one up until you find the thickest one on the box. And as you continue to go through all the pin chambers, you'll find a few of them will set, maybe more of them will set, and eventually you'll get them all to set. And And then once you get them all bound, then the plug will go ahead and turn and open up. So it's not that difficult to start with, but once you do want to get the hang of pin by pin, if you want to go ahead and start working on security pins. So security pins are something that were introduced to kind of help support lockpicking. One of the things that you can see there is that you can set the driver pin, but it might set at the wrong location. It might set in the middle of the driver pin. Mushroom pins kind of operate similarly. Serrated pins have serrations all the way up and down, and they bind at every location, and they're fairly difficult. American locks and use those. They're pretty difficult. But the spool and mushroom pins, once you've got the hang of basic picking, they're a fun step up and move up to. So if you hit a security pin, let's say if it's nice, pick it twice, you'll clearly set the pin stack, you'll feel the plug turn a little bit. You might have all the pins set, but this one pin stack is not working correctly. And sometimes you can kind of get a feel where it feels like it's set, but it's way too high up. Normally you would expect your pins to be further down, depressed down further into the chamber. And so if you go ahead and back off with your tensioner, and it's kind of strange, but back off with your tension wrench, and you feel like you're going to let all the pins snap back, but if you don't go back all the way, you can go ahead and push the pin stack past the top of that mushroom pin or spool pin and get it to set all the way. It's a lot of locks, if they have a spool pin, they might have 2 or 3 in there. So tensioners, if you start to pick, you'll start to have a need for different types and sizes of tensioners. There's also, I like to keep shim stock, like some brass shim stock in my pick case. Sometimes you need a tensioner that's thicker to give you less play inside of a Keyway, so that can be a good material for that. For sourcing material for tensioners, flip out laundry baskets, have a good 12 feet of tensioner material in them. Windshield wiper blades, street clippers as well referenced. And of course, there's nothing magic about commercially made pigs other than usually they look prettier. I like to use hacksaw blades, grind them down, get different shapes of hooks and stuff. Then the only thing is you need to heat treat it because it will be a little softer than your stainless steel you're used to if you have a commercial set. And if you just go to your kitchen, put it over the gas range, and get it to a nice cherry red, and punch it, that'll get you the stiffness you need out of like a wood or something. So worded locks and keys, another technology, fairly old, but folks used to use. Basically, there's these little wards in the lock that block the key from turning, and the key has to have a matching shape that allows the key to turn. There's only one location usually where the key actually makes contact and operates the lock. You could grind off, make a universal key in a lot of cases. Making your key simpler, it just needs to make contact with one point inside the lock. This is more modern skeleton keys or an example of a worded lock system. This is also a style of worded lock. You can see these very commonly. Again, if you ground off some of the spaces there between the key and just like left the tip, you probably have a universal key that would operate most of the worded locks we ever made this particular one. You see these, you can tell some also sometimes by the Keyway. It's very simple looking. Master even still makes worded locks, and I just kind of cringe when I see people using stuff. So the set of worded bits. Basically, it doesn't need to match the key at all. It just needs to make some contact with a small part of the inside of things. You make one out of a coat hanger if you need it. It's not too difficult. Another type of lock is a wafer lock. They have ordinary cabinet locks or commonly wafers, desk locks. This one over here is actually double-sided. Wafer lock is a little bit more difficult. You can see the little thin wafers stacked up side by side, and the key just pushes them, lines them up in the correct position. Now, it's simpler from a manufacturing standpoint to stamp out wafers than pins. That's why they're popular. But yeah, most people can pick, their desk wafer lock instead of paper clips or something. Now, there are wafer locks that are high security. Most automotive locks are actually wafer locks, and so it is possible to make wafer locks that are actually difficult to pick and actually secure. Again, a ball pick, what I mentioned previously, is actually, this is one of the locks that's intended for, because the wafers have like jagged edges or sheets of metal that slide up and down next to each other. Half the time it doesn't feel real good across it. It's kind of like boom, boom, and the ball's got a more rounded area, so it kind of slides across better. Also, because the ball is round on both sides, you can pick both sides of a double-sided wafer lock without having to pull your pick out, turn it around, and put it back in. So the wafer lock show up in lots of places. They have lock. So tensioning, like say a double-sided lock like this, there is a special pick called a wishbone pick. You can also use a regular tensioner and put it in the center for center tensioning. So you don't have to have a wishbone. A lot of times the wishbone still doesn't work very well. You go back to just regular tensioner. Stamp guns, which a lot of people ask about. You pull the trigger and the little blade that sticks out snaps up, and it works a lot like bumping. It's kinetic energy transfer from the blade to the pin and then to the top pin, which jumps up once you get it to the top pin. So the driver pin is jumping up above the pin stack, and so it's not automatic. You still need a tensioner in there. You need to do tensioning very lightly. And just snap, 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 and you can get it. This isn't going to work on all types of locks. Like it's not going to work with wafer locks because wafer locks don't have any mechanism inside for that to operate. But it'll work on those particular locks. You can make a kind of a homebrew stamp gun as well. I've had a little bit of success with that. And again, so this kind of leads into bumping. So bumping operates the same way, except you've got a specialized tool, a key that's cut to a specific position. So let's see here. Basically, this is what's happening. This is showing the normal bump movement. Bump sets that we've got in the vendor area over there are, if you wanted to do this, there's two types of bumping. There's one where you put the key in one position from all the way in, and you smack it with your bump hammer or some tool, and pins like jump across the shear line. You can also do minimal method, minimal bump method, which is where you take your key, you shave down your shoulder, and you shave down the tip of it, and put it all the way in. But because you shave down these components on the key, you can move in a little bit further than what a normal key could, and you can just smack it repeatedly with your bump hammer and get the same effect. It's a little bit more gentler on the lock. I find it takes a little bit more practice to get that right. If you're working on high security locks, this is probably the method you're going to work on. What I'll say about bumping is that it's not that bumping works to open cheap locks. You can pick open cheap locks easily anyway, but bumping will work on high security locks that some folks thought were unpickable. There's some countermeasures that can be implemented, top gapping, so that that key pin in the very innermost one, if it gets bumped, it'll lose all of its energy immediately as it hits that top pin, and it doesn't transfer any energy or enough to really matter. I believe I'm not familiar with any locks that implement this. there's, I believe there's just so little mass or something to transfer with the second one. There's, so Kwikset is known for a lot of folks to be a very easy to pick open lock. And eventually, after taking a lot of use in the last 10 years, they finally came out with the SmartKey system. It does two things. One is it doesn't react to bumping. The mechanism cannot be bumped. In fact, it's likely if you try to bump one of these, it will destroy the lock. And then at that point, you can't open the lock and you're stuck outside or whatever, unless you do some other brute force method to get through. The other thing is that the selling point of the Kwikset SmartKey from their perspective is that it allows end users to instantly rekey their locks. You put in your original key, you turn it halfway, you put in a change key in that little slot right next to the Keyway, with a little black dot there, pull out the original key, put the new key in, pull out the change key, turn it back, and hopefully you haven't destroyed the lock. So a member of our group came up with a decoder for the system. Shane, while his lock is very difficult to pick, or at least substantially more difficult than a regular pin-tumbler lock, it exposes itself to being decoded by the fact that the teeth that make up the top wafer inside, and this lock does not work anything like a regular pin-tumbler lock, can be detected with a little flag, a little pendant on the end of a needle, and that tool basically pushes the chain. It pushes all of the wafers up to the same position, and then there's a slot there for your decoding tool to feel each of the little teeth off the wafer. And so you count the number of teeth, and that tells you the depth of that particular pin, what it's set for inside. So then you go back and cut a key by code, operate the lock. So, combination locks are susceptible to a lot of attacks as well. A lot of times you can pull or push on the shackle and operate the dial combos. That'll give you some feedback to what number should be. If you find a position that's got more play in it, then that will tell you what most likely what the correct number is. If you go through and set all of them, and then eventually you should get the lock as well. You can also use a shim and push it down inside the wheel to feel maybe a gap that's different. This particular lock I'm showing, you can actually visually look down between where that brass shim is inserted. You can look inside and visually decode it. And doing something like that, you just line up when you see a gap, because this is a resettable combination lock. And you just line up where there's one gap that's different, and something looks different from the rest of the positions when you turn the dial. You line all four of the dials up to the same one, and then rotate all four together, each position, until you get them in the correct position. You don't know where the gap needs to be inside the lock. It might not be directly inside to something, but you need to have all four dials lined up together. Eventually, you'll get the lock. Also, this is a TSA lock. TSA locks are not magic or anything. The number on the lock does correspond to a lock, a key that the TSA has on the keychain. They will still cut the lock off if the manager on duty is not available or some of the keys are tied up or something. So you can pick this lock too. On this particular one, it's a wafer lock. You can pick that. So it's a second way to get into the same lock. It's really just a suggestion of security. So there's a lot of different things you can do with keys. Before I get too far, one thing I'll mention is there's something called maximum adjacent cut. And that's the largest number of differences you can have between two adjacent positions on a key. And if you have a key that you can't have like the highest and the lowest position directly next to each other on a typical key. And that's because the key could get stuck in the Mac or Max. And to some degree, like 3 or 4 positions that it needs to be. Now the thing is, of course, that reduces the number of differs in the system. So a lock manufacturer may advertise all these possible key combinations, but the real number of combinations is significantly reduced because of Max. Depth and space keys. So basically, your bump key is cut all the way across to the deepest position for what's sometimes called a 999 key. That not all lock systems use 9 different depths, but a lot do. And so depth and space keys are really used by locksmiths for cutting keys by code on a key duplicator machine. But again, it's handy to have them for different purposes. You might want to try working on some master key systems. I'll get to that here in just a little bit, but it can be handy. But most people they know what a depth key is because they've seen a bump key. So that's a set of depth and space keys. You can see that every position all the way across the blade is cut to the same depth. So master pinning is important to know because, of course, that can possibly lead to positions that the lock will be opened up at. The other thing, is, of course, is if you have a large building with the master key system, the lowest hanging fruit, say the janitor's closet lock, if someone can get in there and get the lock out and figure out where the master wafers are, this position in this picture, they're green, those little wafers. They will be able to figure out the combinations to try and possibly elevate their privileges in the system. You can, again, if you have access to the lowest hanging fruit in the system, you can figure out a number of different combinations. You can have different keys and try the other positions in stack and try to elevate your privilege, see what keys, if your key will work in your new key that you've got in other systems, other blocks in the building. Basically describe that here. So I'll talk about impressioning here next. This is kind of another key-based attack. Impressioning is interesting because it works on a lot of different systems. I saw a talk a couple of months ago in Nicholasville, and they basically, someone was showing how to impression an alloy classic lock, which so an alloy works in a completely different way. It's a disc mechanism. It's not a pin-based lock. Other types of locks, like some automotive, like ignition locks, are around using like sliders and other mechanisms. And you put the key in, you put a blank key in, and you can sometimes get marks on the key that will help you to open it up. I'll start with tubular locks, and unfortunately, my videos aren't going to play, so this is going to be less impressive. But everyone, I think most people see tubular locks on a vending machine. There's most commonly, there's like a 7. There are high security tubular locks, but they're not used as commonly as they should be. This is a tubular impressioning tool, and little sliders sticking up above the top of the tool basically allow it. They retract into the tool when you're pushing it in the lock, and will stop being pushed back once it reaches a shear line inside there. So you can basically put it in the tool and put the tool in the lock. You twist it around, and it will open up. I'm sorry I can't play the video for you. So again, that's a tool that does impression. Now we'll cover manual impression. Some things you need is a pip file, a vise, and supply blanks for the lock system and the lock we're working on. This is just need a little bench to mount it to, good lighting. And pip and file, is one thing that's a little bit unique. A high quality file I would recommend. This is like a $50 or $60 file, lock fixed chainsaw file is too small, it's too rough. You need a good, like a number 3 or number 4 surface on it. The pip and file is safe. If you look at, like, if you're going to poke yourself in the eye, it's a teardrop shape. And you want the round, that nice round shape so it's an untouched blank. You prepare it, you use a flat file for that. You shave off the top, give yourself a nice surface area where the marks can be allowed. You grab it with your tool. You can get special purpose impressioning tools. Vice grips will work. Grab it. You turn the key in the lock as hard as you can without breaking it, and shake it up and down. And then you turn it the other direction and shake it up and down. And you do this 2 or 3 times. And after that, you pull it out and you look at it, and you should find marks on there. Now, the trick to seeing the marks is having the right kind of light and using the right kind of key blank. You want to use brass. You use steel, it's going to sound awful when you're filing, and you're not going to get any marks. Aluminum is too soft, and you're going to break the key off. Brass, or at least even if it's nickel coated, as long as it's brass in the middle, that's what you want. And you can just barely see some dark marks on there, but I've got the arrows indicating the marks you're looking for. And this is just showing the difference in the angle. When you look at it, you just want to rock it back and forth. I like sunset. It allows me to see the light just right, but different types of lighting, fluorescent lights will affect it differently. And just rocking it a little bit, you can see some marks becoming more visible in raw photo from the 2 positions. Also, spacing is fairly important. You'll find a lot of marks on the surface of the key. The trick is figuring out which are the correct. There are some tricks for helping with this all cover here. You can fix that spacing as you go along. You can start filing towards the back of the key. The back 2 positions I've got too close together. I started filing too close together. And what you do, you stop filing, you stop seeing marks. So once the pin stack gets to the correct depth, it stops leaving marks on the blank, stop filing. If at some point later on, while you're working, continuing to impress it, you start seeing marks again, start filing. Also, when you get to the very end, you get what's called a crater in there. And you want to keep going past the crater, but you want to be very, very careful because the crater, basically the pin is wedging itself into the key and you're getting a nice, very big visible mark. And that's, you're really close, or you may actually get it to open at that point and have a big crater. You can make it work a little bit better if you just hair more material. But basically, stop filing and stop seeing marks. I mentioned the maximum adjacent cut earlier, partly because you need to pay attention to this when you're impressioning as well. You can get these deep valleys and sharp points that get into the key track inside the box. You need to be really careful there. What you do is take a flat file or a pin file on the side and take off, make nice smooth ridges in place where you're getting deeper on the key. So you would take off that little narrow ridge and that little piece up there that have better slopes on it. And this is a progression of starting with just a couple cuts on the key all the way to a final working key. And you can also notice I'm starting to break away the head of the key from the blade there. If you start to see a crack, you want to stop. If you go any further, like, oh, I can get a couple more out before I have to start over with a new key, you're likely going to break it. So what you can do is file your next blank down to the point where you're at now and keep going. You've got that much more work you can do. But again, you have to put a lot of force on that blank in order to get good marks on it. So eventually open it. If you've been picking for a while and you're kind of getting bored, try impression. It's a new rush, it's a new field again. You will leave marks on the plug, because again, you have to work this thing pretty hard. This is what I was talking about, where you start to crack the key in half. You don't want to, it's very easy to get the key stuck in the lock. And that's, if you really got some deep valleys in there, it may be almost impossible to get that blank out without disassembling the entire lock. There's other tricks, again, like using the shallowest depth key as a blank, duplicating that so that way you have the correct spacing across the blade of the key. That way you don't have to guess about spacing, plus all your positions are already at the number 1 cut. So if any pins happen to be at that position, that's less 500. Competitive compressioning, there's a lot more tricks you can do. There's a good book by Oliver Dietrichson. The English isn't the greatest, but the information is top notch. He's a German fellow. I've got the book with me. I'll be in the village after this if folks are interested in checking it out. It's an interesting technique. If you need a key for a lock, that's one thing, but also if you're, say, doing a physical pin test or something, and you need to, say, you can pick off the lock, take it back at your convenience, and press the key for it, put it back in place, and then, the next time you need to go deeper into the system, you can just immediately go to that previous barrier without worrying about people taking 10 minutes or 30 seconds. You can apply, like I said, there's a lot more tricks to it too that you can use for compression. That's the long and short of it. Again, I've got a video that I can't show, but foil impression with dimple locks is fairly interesting. So a dimple lock is basically a key where instead of having cuts along the blade of the key, there are basically divots drilled into the side. And this lock that I've got here is a lips octadrill, and it's got pins on 3 axes. And on the key on the left is the actual key in the middle is the blank, the key on the right is the blank that I prepared by just drilling it out with a Dremel and making all the positions deeper, deep enough, a little bit deeper than what the deepest position could be for each pin stack. And what this does is you can wrap it in aluminum foil, put it inside the lock, and kind of work it, and the pins will work their way down into the aluminum foil, and then eventually, once they reach the right depth, they'll stop pushing further, and very often you get a dimple lock like this. So, chocolate dimple keys, effective against dimple lock figures. So more advanced lock features. There's what's called keyways. As you start to pick, you'll start to notice more keyways and different. You can recognize the lock brand by the keyway. Their wording is also used to refer to the difficulty of the keyway. Like words are basically the metal the key is going around. There's specialty mechanisms, things that work with sliders and other things. There's also locks that have trap systems. So a couple high security locks that we've come across here in North America. Schlage has the Everest system. It's got this little double triangle on the front of the plug. There's a special finger pin in the back that you have to trip. So if you don't recognize that this is an Everest and you're going to pick it, you're not going to get it. You need to be able, in addition to picking in a regular sense, you also need to have a tool that will reach back and set this. The keys have this little ridge on the side, this extra ridge back there. Has anyone heard of Matt Blaze? Matt Blaze is a pretty cool dude. He worked for Bell Labs at one point, did a lot of work on Clipper chip and other things. But he has some fun papers on lock picking as well. One of the things he talks about is just making a tensioner out of a blank. It's mill the key down. So it's just the component over there that trips the finger pin, and there's still plenty of space for your picks to get in there. So you can do that. You can just take a little piece of brass shim stock again, just push it back in there, and there's a groove that will hold everything in place. So you just put that in there for it over, begin picking. So the Schlage Primus. Primus is a totally different lock, although there's also the Everest Primus. But Primus is a pretty cool system, but unfortunately they implemented some technology for it. But so there's a second set of fitting along the key. You can see in the plug, it causes the second set of fingerprints that are inside the plug both to move up and down, but to twist as well. And that allows the sidebar, which isn't really shown very well, but it would be along the very top of the plug. It would stick out and lock the plug turns by itself. Once both all the pins and the additional finger pins are set, then you can go ahead and turn the plug. The problem is the Primus, the sidebar pins on the key are cut at the factory. So if the locksmith wants to use the system, they'll get a Primus system from Best, or not Best, Schlage, and they'll all their customers will then have the same sidebar. So you could potentially buy a lock from that locksmith, make yourself a bump key, make yourself a special tensioner that just implements that sidebar and pick the lock as normal lock. Same thing with master key systems. Say a building or a university or something may have a Primus with a Primus system. We'll have the same sidebar cut in all the locks. The sidebar is not used in the master key system. So that way, again, if someone has access to a generator closet, they can modify their key, or lose their key, get another replacement, and then take that lost key and turn it into a tension wrench by milling it down just to the top of the sidebar pins. And then you've got a tensioner that nullifies the sidebar. So again, the sidebar system in this lock is beautiful. It's amazing. It was actually designed by the same engineer that designed the awesome Twin system. It's even more sophisticated than that system. But again, the way it's implemented is not great. But again, part of the reason the company does this, they want to advertise key control. They want to make sure customers can't get a duplicate of a key unless it comes from either their local locksmith that's supporting the system or directly from the factory. So that's why they implemented that. Knox Boxes, I think folks might have an interest in. People seeing these outside the buildings, businesses. If you look around as you walk into a commercial building, you might see one of these. And these are controlled by the local fire department. It's basically a little key vault on the outside of the building. There's the fire department has one key that opens all of these, so they can get in. This is the component inside the fire truck, the fire chief's vehicle. And the key on the front is actually the key that would open the safe inside of the building. This gives you the ability to control who has access to that key. It's a dual two-factor authentication with PIN code, the fire codes, and it's something that's sent over the radio to operate unlock the box. And then it also has USB auto capability. We've got some newer versions of this now. Just larger auto trail, of course, and they now have something that responds to having to maintain the auto trails kind of pains. Someone needs to physically go to each vehicle and retrieve the auto log, so now they have the Wi-Fi. I've not had a chance to play with any of these yet, but I'm curious. I hope they know what they're doing. I have Wi-Fi. I think if I have something, we'll find out. So the lock in the actual Knox boxes themselves inside the building is it's Medeco. Medeco is it's a nice lock. It's got a sidebar design. They have come under a lot of attack in the last 4 or 5 years. So you can see the pins fitting along the key actually is at an angle in addition to separate depths. pins have a chisel tip on them, and it causes the pin to twist. And just like the Primus, there's a sidebar inside that falls down. It's got little fingers that go inside the grooves of the pins. So a couple of years ago, a fellow by the name of John King rediscovered a tool, a method of picking these locks. Basically, it's a piece of piano wire, and because that groove goes all the way up to the top of the pin, you can reach inside of that this tool and rotate it back and forth. So you have a reliable method of rotating it. It's got graduation, so you can tell which pin you're at inside the lock. So you can pick up the normal lock, and the sidebar at that point is just blocking, and you pick all the pins with the sidebar. And Medeco knew about this some time ago, and they had a solution, but they just kind of quit using it because people were talking about that method of opening the locks. So the problem is mass manufacturing techniques. You need something that's easy, and just having a tool that just cuts, a bandsaw or something that cuts a groove to the pin in one fell swoop is easy, but having that not get all the way to the top of the pin so the groove is not exposed inside the keyway is more difficult. You have to custom mill that. And so that's what Medeco does. The ARX on the left, and Medeco re-released the ARX pins. They were reasonable to work with, apparently, although they didn't do the greatest job of communicating information out. So there are other attacks against Medeco, but I'll just stop there on that. There's a book, Gone in 30 Seconds, or Open in 30 Seconds by Bias that has some more information on that. So Best is another common brand. They're used a lot in large institutions. They have a lot of, they use what's called these interchangeable cores that can be switched back and forth very easily. You can pop the core out, put a new core in, and that's part of the self-point of the design. They're fairly difficult to pick because there's actually two shear blankets inside. One of the things they do a lot with is different keyways. There's a lot of different keyways to their lock systems. The keyway have different shapes to the keys, so lots of different key blanks. And they will, they like for companies to buy custom blank systems for their new buildings and stuff to help ensure that someone can't just go and count one of their keys. I know apparently in my hometown, if you take one of the university keys to a local locksmiths that are in several places to try to have one of their keys duplicated, they have directions. If someone's trying to duplicate this, call campus security. So it's a little bit more challenging for just the average person to go, unless they're willing to do a little bit more work to get copies like this. So there's a lot of cross-licensing technology in the lock world. Lori invented a system called Peaks. Basically, it's a key blank that's a little bit different from the rest. That right up on near the outside of the lock, above and below, there's a little sticks above the key. Like there's a normal blade, and there's these two little ridges on the key that stick out. And a normal blank doesn't have that. And so it's not like it's not a huge difficult component to pick, but it is difficult to get a key blank for this system. And so that's what the protection is. So again, you can use some wood steel or something to add material to otherwise working blank. They typically use some different keyways that you can't just take one keyway and just add some material to it. You need a proper blank for it to even fit inside the lock. They've got a new system called the MX8. Basically, it's got a little pink component, and it's not really pink, but a diagram there that blocks the plug. It's not very difficult to pick. Again, you need it's not very difficult to pick that component. It's still a difficult lock to pick, because most best locks are fairly difficult. They're also usually 6 or 7 pin lock. But to deactivate this component, you just need a wire or something to push back and push that one component out of the way. So that's an example of one of the keyways they've got for that. There's lots of other attacks too, bypass attacks. This is a cone pick. It'll basically push all the pin stack, the entire pin stack up all the way out of the plug. It will also, some like on house locks, this can quite often break the lock and pop all the pins out of the back inside. So you'll mount your door with full pin components if you do this. But a lot of padlocks will work and it won't be any problem or any damage to the lock with this. The solution is to use a balanced pin stack. Again, pay a little bit more money for a lock, you're going to get a little bit better designed lock. The driver pin, the one on top in your keyways, will, in a better lock, will be when you have a smaller key pin, you'll have a longer driver pin to match so that this technique won't work. So we get kind of close on time, I'm going to jump ahead here. So again, physical security, the lock is just a small component. Gaps in door frames are bad. Gaps between double doors are very bad. In a commercial doorknob, usually it would be like it's called a D clip, or this little piece of metal, if you look straight on at it, it's shaped like a D. The shiny component right there next to the strike is actually what I'm talking about. It's supposed to, when the strike goes out, it's supposed to be held back in place. And if the door is aligned or just messed up, or the hole for the strike is like stretched from being slammed hard, if that is allowed to slide out too, then you can jimmy it open with a credit card for doors that should be resistant to that. When you get, when you're going through a security door, you need to remember, did you badge out? Or if you had to badge in, how did you get out? If you used the badge to get out, okay, if it just unlocked as you walked near it with a motion sensor. If you can get something underneath the door to the other side, it's not very clear, but a coat hanger with a piece of paper on the end, you can trip the door with that. Or if it's double doors, getting a piece of paper or a piece of binder through it, wiggle it around, off the trip, a motion sensor. If the gap is wide enough on some double doors, you might even be able to get a tool on the inside of a little push bar system and pull that push bar back. So gaps, being able to get anything through the door is bad. Drop ceilings, you look at the fire code for the building and see, where the firewalls are, what the firewall code is, how far the firewalls have to go up. You can see where the rooms that might be, that weren't really built with the building, they were built after the building was built, so there's not going to be a wall to wall that drops it. So be aware of that, server rooms. So you get physical access and get things over. Biometrics are, again, their own thing. $2,000 hand scanner, hand-shaped scanner, but it's secured to the wall by a 4-pin computer case lock. A lot of people, I'm sure, have seen the kryptonite attack on bike locks. Same thing, except this is a smaller size. So it's 5/16 brass tubing, cut a little notch in it, twist it around so you can turn that inside pin and inside the plug, and it's all over. It's just a relay system. You can bring a couple batteries with you. Hot wire the relay from the door with that. So, and go ahead, get close to wrapping up here. That was my front door from December of last year. So again, being resistant to brute force is really your main concern. You can get reinforcement plates at the hardware store for cheap for your deadbolts and your doorknob. There's a commercial product called Door Jam Armor. That reinforcement comes with these. It also has reinforcements for the door hinges. Get some 3 or 4 inch screws. Get a security strike, something that has more bolt holes in it. One security strike is one that has like a shell that goes in the wall. Screw holes in it, so you can get screws at that point. Don't just go home, take out, buy some 3-inch screws, take out the screws from the strike plate. If they're like a 1/2 inch long, they just go into the molding. They're not going to stop kicking. Just go replace those with 3-inch screws. Do the same thing in the door hinges too. If that's not enough security, you can go a little bit more versatile. There's a dude on eBay that used to sell this rig. And you can also get real security doors. I think Winchester used to sell this bedroom door that had bolt work up and down the side. Don't forget your windows, because once you get your door to where it can't be kicked in, what you can do is get security lamination, put over your windows. If you're a residence, you can put lamination on. If you're a business and you have a little bit more budget or something, you can get more, like banks will use a system where the lamination actually goes out to the windowsill and is bolted down, so that there's a lot more security there. And so eventually someone can still get through your window lamination, but that gives you enough room to get enough time to get to your safe room. And of course, the safe room is a target, so they can hit the roof of your house. I guess briefly, I just enjoy logs. I collect high security logs. I'm always interested in different security and stories. If anyone has any questions, they see something like, I want to know what this is, please feel free to contact me. DOSman@livingtools.org. We also meet, like I said, once a month. I'll be like 10 if you're in the vicinity. I'll stop by, check